Now that we know how to do definite integrals, we need to look at the concept of what we started with this whole time, which was the area under a curve. When we started talking about integration, we said that was going to be our goal, was to be able to find the area underneath the curve within a specific interval, okay? Now, in this case here, we're asked to find the area of a region enclosed by the graph of y equals x squared plus 1. So that's the parabola you see here. The x-axis, x equals 1 and x equals 2. All right? And I would always recommend, if not actually sketching, at least visualizing what the graph looks like. Okay? Because this is the area that we're trying to find. This what looks kind of like a trapezoid, but it's got a curved top here, because it's made by the x squared plus 1. Alright? So what we're trying to do here to get the area under the curve is we're going to take the integral of x squared plus 1 dx, and we're going to take it from 1 to 2. Okay? So, what's the integral of x squared plus 1?
1/3 x cubed plus x.
Good. 1/3 x cubed plus x. And I'm going to evaluate that from 1 to 2. Okay, using our fundamental theorem of calculus. So, I plug in the upper bound first, so that's going to be 8/3 plus 2 minus, I plug in the lower bound and I get 1/3 plus 1. Okay? 8/3 minus 1/3 is 7/3. 2 minus 1 is 1. So that's 2 1/3 plus 1, which is 3 1/3. Okay? So that is the area underneath our curve. So now, here's another aspect that we have to consider, and we're going to do a couple of things here. One of the things it says find the area enclosed by one arch of the curve, y equals sine of 2x, and the x-axis. Okay? Now, you're expected to know what the graph of sine is. It has a period of 2 pi, and it goes up to positive 1 and down to negative 1. Okay, it's up at 1 at pi over 2, and it's down at negative 1 at 3 pi over 2. Okay, so our sine curve looks like this. Okay, now they want the area enclosed by one arch of the curve and the x-axis. Well, they haven't told us what the bounds of the interval are, but they did say we want one arch of the curve, okay? So, by the way, area enclosed by is another way of saying total area. So if there were, if we did happen to choose the arch that went below the x-axis, we would make it positive anyways. Okay. Now this is sine of 2x. Okay. What does that 2x do to us? Or to the function?
Vertical stretch or something?
It's not vertical. That would be 2 sine of x. Okay. So what does it do to our period, since that's what determines how wide it is?
You
Yes.
multiply by 2? No, you don't.
No, it become wider. Like, of
If you
times,
just
2
find
times
the area of
wider.
sine of x, you can calculate it.
Okay. Not quite. Remember, horizontal transformations are always the opposite of what you think. Okay? The vertical ones, if you saw a 2 sine of x, yeah, that doubles our amplitude. if you see sine of x and then plus a number, it's going to move it up. If you see minus a number, it's going to move it down. The horizontal ones are opposite. So like on the translations, if you see x minus 3, instead of moving to the left 3 like you might think, it moves you to the right 3. Same thing here with the period. When we see a 2x, it doesn't double the period, it actually cuts our period in half. Okay? So, this is actually going to be just pi. And each of these is also going to be cut in half, so that's going to be 3 pi over 4, pi over 2, and pi over 4. Okay? Instead of being stretched out all the way from 0 to 2 pi, now it's compressed into just 0 to pi, half the distance. Okay? So that's what that 2 tells us, the period. And if you remember the relationship, it's always 2 pi divided by that number b. We usually used b for that, 2 pi over b. So 2 pi over 2 is just pi. Okay? So, why did we have to go through all that? Well, that's how we know what the bounds are for our interval. Okay? So, I'm going to go from 0 to pi over 2. Okay? Now I can take the integral. Any questions so far? Okay. Now, how do I take the integral of this? Okay.
And then you plug it.
So what's the antiderivative of sine of 2x? Okay, negative cosine 2x. How do I account for that 2x? It is linear, so we don't have to do the full u substitution thing, but what do we have to do?
1/2 cosine.
What?
1/2 cosine.
Yes, it's going to be a negative 1/2 cosine. Remember, you multiply by the 1 over a? Okay? So that is our antiderivative. We're going to evaluate this from 0 to pi over 2. Okay? So it's negative 1/2 cosine of 2 times pi over 2 is just cosine of pi. But then we subtract a negative 1/2 cosine of 2 times 0. Okay, so it's negative 1/2. What's cosine of pi?
-1.
-1. Good. -1. Minus a negative 1/2. What's cosine of 0?
Just
1.
1.
Okay, so this is going to be a positive 1/2 plus 1/2. So our area equals 1. Okay. Now, let's take this kind of one step further. So extending this idea, what would the integral from 0 to pi of sine of 2x dx equal? Zero. Okay? It would be 0 because if the top was a plus 1, the bottom's going to be a minus 1, right? So that's going to be 1 minus 1, which is 0. Okay? Let's take it one step further. What if I did the integral from 0 to pi of absolute value of sine of 2x dx? That would be 2. Because it's 1 plus absolute value of -1, which would be not 0 anymore, it would be 2. Okay? So, this actually brings us to an idea here that we need to be careful with, and that is, if you have a function that you're trying to find total area of, and it goes underneath the x-axis, then you need to find whatever zeros there are and make sure that you adjust, okay? Let me add one problem here. Suppose that we want to find the total area enclosed by y equals 4 minus x squared, the x-axis, and the lines x equals -1 and x equals 3. Okay? Now real quickly, let's sketch this just so we know what we're dealing with. Okay? First of all, this has zeros at 2 and -2, right? So we've got that. It's going to hit the y-axis at 0, 4. Okay? So here we have our parabola opening downward. Okay? Here's the problem though. If I go from -1 to 3, I'm trying to find this area enclosed. Okay? Does that make sense to everybody? You see what we're doing? Okay? So question. If I do the integral from -1 to 3 of 4 minus x squared, is that going to do it?
No.
No. Okay? If I do that, that's going to give me the net area. In other words, it's going to give me the area above minus that area below. Okay? So it's very important that we understand this and we pay attention to what we're actually looking for. We're not looking for that, we're actually looking for this. So the question becomes, how do we handle that? We mentioned this a little bit earlier. Does anyone remember? How do we take care of that, or handle the fact that we want total area as opposed to just the integral? If I want absolute value, I need to make that part down below be positive, right? Right?
Would the absolute value do that?
The absolute value will do that, okay. But I don't know how to take the integral of an absolute value.
So make it backward.
What are you talking about?
Saying like using x squared minus 4.
Oh, okay. So flip it upside down or something. That would flip it,
Yes.
but then the first part would be below and the second part would be
Can't you
above.
just do it and then make it negative, or make it positive?
Okay. What part is going to be negative though?
From
That's it.
So you have to do two separate integrals.
You have to do two separate integrals, okay? The integral from -1 to 2 is just fine. We're going to do that, 4 minus x squared dx, no problem. But then we need to do the integral from 2 to 3 of 4 minus x squared, and we know that that is going to be negative because it's below the x-axis. So you could handle this any of a number of ways. Sometimes people put minus the integral, so they'll have minus a negative. Other people prefer to just put a big ol' absolute value around that part. Okay? So whatever they get, they just make it positive. Alright? So now, I know that the integral is 4x minus x cubed over 3. I'm going to evaluate that from -1 to 2. I'm also going to do the absolute value of 4x minus x cubed over 3, evaluated from 2 to 3. Okay? So, if I plug in a 2, I get 8 minus 8/3. Minus, if I plug in a 1, I get -4 minus a -1/3. Bunch of negatives there. Be careful with that. Plus, and I'm doing a big absolute value here. Here I'm plugging in 3, so that's going to be 12 minus 27 over 3. Minus, plugging in 2 is 8 minus 8/3. Okay, and now it's just a matter of simplifying. Okay, 8 minus 8/3 plus 4 minus 1/3 plus the absolute value of what's inside here is 12 minus 9, which is 3, minus 8 minus 8/3 is 24/3 minus 8/3. That's a minus 16/3. Okay, well 16/3 is 5 1/3. Okay, so that's going to be, when I take the absolute value, that's going to be a positive 2 1/3. This whole thing is 4 minus 9/3, so 4 minus 3 is 1. Or, sorry, not 12 minus 3 would be 9. So 8 plus 4 is 12, minus 9/3. 12 minus 3 is 9. So this would be 11 1/3. Okay? Is our total area. Okay. All right. So